P.4 notes. So this would be day 2 of the P.4 lesson on factoring and trinomials and grouping. So that's what we're going to go ahead and take care of now. These were the 3 independent practice problems you had to finish from part 1 or day 1 of the lesson. So I just wanted to give you the opportunity to check yourself before we get going into today's events. Yeah, so yeah, take a second. I didn't show work for part A, but I can. So you just let me know if you'd like to see that. I'll go ahead and give you a few quiet moments to look this over.
9 and 2.
So here in example 4, if you're struggling with AC grouping, we can take it back just a notch and just focus on grouping. So that's the strategy I need to teach you in day 2 of this lesson. So here in example 4, it says, how do we factor with more than 3 terms? Well, you actually already know how to do this if you can AC group, because I taught you how to group it. And that's the focus of today's lesson. So let's be honest, you can highlight a little bit with me if you would like. In some cases, there is not a GCF for all of the terms in a polynomial. And truth be told, if you have 4 terms with no GCF, then grouping is the way to go. So just straight grouping. And step 1, you group the first 2 terms together and the last 2 terms together. I'll go ahead and let you know I just split the problem right down the middle with a squiggle. Some teachers get very fancy with their quantities, but I just squiggle it up. Then you're going to GCF, not once, not twice, but 3 times. And that will leave you your factored response. So let me show you how this works. First of all, observe why we would do grouping on this problem. So you see how many terms we have? 1, 2, 3, 4. We have 4 terms. Also observe that there is no common factor. Like kids will be like, oh wait, but like 2, times 7 gives you 14. Well, remember it has to be a common factor in everything. So this guy here kind of is getting left out to a certain extent. Also, not every term has an X in it. So there is no GCF. 4 terms, no GCF. What we're going to do is we're going to break it apart into 2 problems. So that's the grouping step. That's step 1. Just put a squiggle down the middle. Careful not to swing through a minus sign if it's there. That will matter. Okay, and then literally you just focus on the first 2 terms. X cubed plus 7x squared. And your mission there is just to take out a GCF. Any takers?
X squared.
It is x squared. The only thing they have in common is an x squared. So they don't have 3 x's in common. They only have 2. And then, this is the part where we kind of do the distributive property in reverse. So you ask yourself, x squared times what gets you back to x cubed? It is an x. Good job. Thanks, Damon. And I'll bring down my plus. And then I got to ask myself, x squared, you're good, times what gives you 7x squared? It is a 7. Nice. So that part's done. On to the other half of the grouping. Yeah, you're welcome. All right. I need a GCF. Oh, it is. Good job. 2 goes into both of those things. Yep. And then we ask ourselves, 2 times what gets us 2x?
X.
It is
7.
nice, guys.
That's supposed to be mine.
It's a race. There is a winner and a loser. Yeah. So yeah, we have 2 times the quantity of x plus 7 there in making 2x plus 14. Those are logically equivalent. Okay, wait. It gets really cool. Look. X plus 7 is there twice. So that is our friend from last week called the repeating binomial quantity. In other words, this set of parentheses needs to match. If you were getting particular about things, you could bring your plus sign down. Not that I'll judge, but, there was a plus sign hanging out in between. And so I did say when I was explaining the steps, you actually GCF 3 times. So what you're going to go ahead and do is pull the x plus 7 out. It's now a greatest common factor. Here's what I mean. If you look at this is a term right here. You can put a box around it. We also have a term here. The factor that those 2 terms have in common, the thing that is the same in both of those red boxes, is the x plus 7. So you could pull the x plus 7 out of the problem. And then essentially what you're asking yourself is x plus 7 times what gets you x plus 7 times x squared. And it's just x squared. You bring down your plus. And then you ask yourself, well, hey, x plus 7 times what? X plus 7 times what gets you 2 times x plus 7? And that's just 2. Now that's me explaining the sort of theory behind it, but honestly, the x plus 7 is the thing that repeats, so you bring it down like you did last week, and then you just write what you have left over. X squared plus 2 was what was there on the right side. So x squared plus 2 was our leftovers. That's what we wrote.
What? Okay.
You good?
Yeah,
Okay.
I had x7 in the back.
Oh,
So I just looked.
got it.
Okay.
Either or. Multiplication's commutative like that.
Miss Lucas, what multiplies to be 63 and then adds to be negative 60?
I don't know yet, because I didn't hear the second number.
Multiplies to be negative 63.
Okay, one more example of this and then we're done.
What's 3?
I can't hear him. Okay, see this guy right here? Got 4 terms, no GCF.
Ew.
It's got an X and a Y in it this time. I know, right?
That's disgusting.
It's disgusting. Gross. Okay, we would work it the same way though. So we're going to go ahead. You got 3x squared plus xy minus 12x minus 4y.
Whoa.
So just focus on the first two. And you just have to figure out what they have in common. Yeah, they do have an x in common. Very good. And then you just ask yourself, you know, x times 3x, or
X.
I just said the answer. I hate when I do that. Did you hear that? I'm sorry, guys. Yeah. X times what gets you 3x squared? Oh,
X.
yeah. How'd you guess?
I'm smart.
You are smart,
Thank you.
despite my.
Why?
Oh, very good.
Thank you.
Okay. And then we do it again on the other side. Whew, it was really fun. Okay, watch out though. If you have a negative leading coefficient, yes, sir, you want to pull out that negative.
Negative
3, 4, x.
Negative 4.
negative 4.
And if you don't, yeah, if you don't pull out the negative 4, you're not going to get that repeating binomial quantity that you need.
Why?
So we would have
Add.
3x.
3x
Yeah.
3x minus 4 and then 3x
Plus.
plus
Why?
y. All right.
Are you okay?
Repeating binomial quantity is hanging out for all of us to behold. You got this 3x plus y and this 3x plus y. See how they match? Oh, it's so pretty.
Damn.
So we will just bring down that 3x plus y. Bloop, bloop. And then write down what you have left over there in red. We got an x and a minus 4.
This.
And you can check it with FOIL. It does work.
Does it matter, like, if you put x minus 4 first?
No, it does not.
Okay.
Yeah. It does not matter the order in which you write your parentheses. So yeah, you just take a second, check that with FOIL.
Oh. Thank you.
Sure.
Okay, wait.
So we have to do the independent practice.
Yeah, we're going to go on to the independent practice next.
All of them?
By the end of the chapter. Even if you know, it's
No
not a
way.
bad idea to leave a couple blank for the end to make sure you understand what you're doing. But you just got to remember to come back and fill them in.
All?
You have a couple of independent practice problems.
Wait, can you go back a second?
Oh, sure. There are 9. The idea is to make you fast. Students struggle with what they don't do often. So if you don't like really,
So we do A.
yeah, we can do it together. Sure. And A is a nice time to remind you about the shortcut. But if you don't give yourself that practice, it never gets fast. And then you're like trapped in this like unclear zone of unpleasant homework experiences.
How do we check it again?
FOIL. Or use the answer key if you're in the homework.
Ouch.
Okay.
That's what I would do.
Does anybody remember the shortcut for part A? Like, do you have to all out AC group this?
That's what I did.
You
just-
did?
Yeah, I don't know.
I forget how.
I only use bullets for shortcut. But for B, would you take out the GCF?
Yes.
Yes.
What?
All right, so for part A, since you don't like the shortcut, I'm just going to AC group this. Ready?
What's 5? Oh.
So we would do 1 times -5.
So -5.
Yep. And the idea is that AC busts up B, right? So we need to think of the numbers that multiply to give us -5 that add to 4.
Oh my god, I'm so bad at this. 1 and -5. -5 and 1. 1 and -5.
You keep saying the same thing.
1 plus -5.
Would it be,
So 1 and -5.
2.
would it be negative
5,
1
negative
plus
1.
1?
5 and -1. There you go.
Still can't go next time.
Thank you.
And then remember that you're trying to turn this, if you're thinking about it, you know, we're not just trying to turn it into, this is me thinking, we're not just trying to turn it into 4, you're trying to turn it into 4x, right? So you got to put your x's there.
Oh, so you put x squared.
You do. You bring down the front part, which is an x squared, and then the back part,
Caboose.
which is -5, the caboose, yep. And then you group it,
Oh, yes.
and we just do the lesson we just did.
X.
So pull out the x,
What?
and you have x minus 1. Here I'd pull out the 5, and I once again have x minus 1. So you get that glorious repeating binomial quantity that we talked about.
Oh, okay.
That set of parentheses always has to repeat. So you bring down the x minus 1,
Yes, ma'am.
goes away, and then what's left over is your x and a +5. So you have x plus 5 left.
Thank you.
Sure. You would check it with FOIL. So the idea would be that we get the same problem back out. X times x is x squared plus 5x minus 1x minus 5. Combine your oi. Oh, look at that. I got the same problem. So it matches. That makes me happy. This matches this. So that means that this here is my answer. And again, you could write it as x plus 5x minus 1, depending on how you wrote how you busted up your B. Will affect how your parentheses kind of look. So those are your independent practice. And then your answers are always in Google Classroom if you need them. But I'm going to kind of navigate away from this slide. But yeah, feel free to check at some point here.